All right, the last thing we need to be able to do with radicals is simplify if we have rational exponents. So again, there's that word rational. So when we see the word rational, it's talking about fractions. So this is saying if we have fraction exponents, anytime we have a fraction exponent, it can be rewritten as a radical. So this is showing how radicals and exponents can be related. So if we have x to the a over b power, so we have a fraction exponent, this can always be written as with a radical. The a is still going to stay the power, the top is going to be the power, the bottom is going to be the type of root. So x to the a over b power can be written as a b root of x to the a power. So that bottom or denominator becomes the root. The way this is written, we would do x to the a power first and then do the root. Now, it really doesn't matter which operation we do first, the power or the root. So this can also be written as the b root of x to the a power. So in this one, we're doing the root first and then the power. Both of those are correct, but we just need to know that when we have a rational or fraction exponent, we have to rewrite it, or we can rewrite it as a radical. And the denominator is the type of root. All right, so let's look at these examples here. A and B, we are simplifying, and we'll actually be able to evaluate and get a numerical answer because our base is a number. So on A, we have 64 to the 2/3 power. So that means the 2 would be the power, and the 3 would be the type of radical or root we would do. So this means I would do a cube root. So one way we could write this would be cube root of 64 squared. We could still simplify this, especially if we had a calculator, but 64 squared is a pretty big number. So instead of writing it this way, it would also be correct if I wrote it this way. Cube root of 64 to the second power. So this way, if I write it this way, I'm doing the radical first, the cube root, which will make it easier. So if I'm doing a cube root, it means I'm trying to figure out what number cubed, or what number to the third power would equal 64. That number that we're looking for would be 4. 4 to the third power equals 64. So that means the cube root of 64 is 4. But don't forget, we still have the squared. So then I'd have 4 squared, which is 16. So after I do the root and the power, my final answer is 16. So 64 to the 2/3 power equals 16. All right, let's do B. So we have 16 to the 5/4 power. So the 5 is going to stay the power. The 4 is going to be the type of root, which means I'm doing a fourth root. I'm going to write it with the root first. So this means I'm doing 4th root of 16 to the 5th power. Now I need to simplify this. 4th root of 16, that means what number to the 4th power equals 16? That number would be 2. 2 to the 4th power equals 16. So 4th root of 16 simplifies to 2. And then we still have the 5th power here. Now I need to do 2 to the 5th power. So that means 2 times 2 times 2 times 2 times 2, which is 32. So this one, the square root of the 16 to the 5/4 power simplifies to 32. Like I said, both of those are able to simplify to a number because our base was a number. Now, if we look at C, it says rewrite x to the 4/5 with a radical. We cannot actually get a numerical answer in this case because our base is a variable. So on this one, the 4 is going to stay the power, and the 5 is going to be the type of root. So there actually is two ways we can write this. we could write it like this, the fifth root of x to the fourth power, where we're doing the power first and then doing a fifth root. Or we could write it like this, the fifth root of x to the root first and then to the fourth power. Either of those is correct, and both of those are equivalent. So here we could just rewrite, because our base was an x, we couldn't actually evaluate or get a numerical answer because our base was a variable, not a number. All right, and now you're going to do a couple practice problems with these.